Today I was dealing with an issue, so I had to compare some brain connectomes from schizophrenia subjects pre and post treatment to find some difference. Now, so the issue was given by the fact that I had to compare the connectomes for these subjects for using different modalities. I had both the EEG and FNIRS for pre and post treatment. Usually what you will do is to use something that is called network-based statistics, which is a tool that was introduced by Zalesky and colleagues in 2010, which substantially you take the connectome acquired for whatever modality, representing connections of functional connections, or structural connections, or any other type of data, and not necessarily has to be brain, can also be other types of networks. And the idea there is that for each edge you do some statistical analysis at the level of the two population. If there is a statistical difference, let's say for a threshold of 0.05 p-value, let's say, if they are statistically different. And you need to do some multiple hypothesis testing because you have several of these edges. Otherwise, you will be lucky with all these edges at some point, and that makes sense. It's not using the Bonferroni correction, it's using another type of correction called related to the subclusters, subnetworks of the. And yeah, the problem is that in each implementation I checked, in BCTPy or Nylearn or networks, you have to upload one type of networks. So let's say you have to upload all the EEG data against all the other EEG data, or all the functional MRI against all the functional MRI. So I didn't find by default any way that I can upload at the same time fMRI and EEG, for example, for the same subject against fMRI and EEG for the case subject against. This is because substantially, well, if you need to upload two different modalities or more, you have to create a multi-layer networks, and this code doesn't work. So what I did is I re-engineered the BCTPy. I rewrote it in such a way that it's loading two different types of networks. For example, you upload the EEG and FNIRS, and it's testing at the same time the edges for the both modalities, comparing them. And then for the rest, it's like the network-based statistic of Zalesky, as usual.